Hello PU2 champions, welcome to day 6 of 21 days challenge to get 95% in your second PUC board exam. As part of today's challenge, I have given you two chapters for revision. The first one was moving charges and magnetic field from physics, and second one is matrices from determinants. So I hope all of you have to you need to revise these two chapters, okay, and practice its most important questions from the PDF I have provided. If you haven't downloaded yet, the link is there in the description section. Please go click on the link, visit the page and download the most important questions PDF. This is very, very important. And in this video, I'll be talking the most important questions from the chapter Moving Charges and Magnetism from physics. And these questions are sourced from PYQs, question bank, model question paper, passing package, and these are very, very important. So do not skip these questions. Okay. So to help you to keep a track of your progress in this 21 days challenge, I have prepared a study tracker for all of you. Its link is also there in the description section. You can download, you can click on the link and please create a copy of this study tracker. Do not try to edit this one. Create a copy and then use it for your progress. Okay. Now let's understand the blueprint of this chapter. So one second, there's a small change here. This chapter has a weightage of 11 marks. Okay, I hope it is visible. So 5 marker 1 question, 3 marker 1 question, 2 marker 1 question, and 1 marker 1 question. So 5, 3, 8, 9, 10, and 11 marks. So let's first talk about this mentorship session that I have started for all of you. So my dear children, if you have any problem in your preparation, do not worry. I'm there for all of you. You can just book a mentorship session with me. The link is there for the description section. Then we can have a one-to-one discussion. We can talk and discuss about all your problems and I can provide you the best solution. Now please remember, every problem has a solution and just it needs to be discussed. So if you feel that I can help you, if you trust me, please do that, try it out. Okay, link is there in the description section. Now let's move to the 5 marker questions. Theory questions will be there. There's no numerical from this chapter in the 5 marker section. Okay, so some derivations you need to practice. So first derivation is with the help of a diagram. Derive the expression for derive the expression for the torque on a rectangular loop placed in a uniform magnetic field. Okay, that is what you have to find out or you have to derive it. Next is derive the expression for the magnetic field at a point on the axis of a circular current loop. Okay. Next, derive the expression for the magnetic field at a point inside an air-cored long current carrying solenoid by using Ampere's circuital law. Derive the expression for the force between the two long straight parallel conductors carrying current and hence define the ampere. Next, with the neat level diagram, explain the working of a moving coil galvanometer or give the theory of moving coil galvanometer. Next, 5 marker model question paper questions. That was question number 39 in model question paper 1. Derive the expression for magnetic field at a point on the axis of a circular current loop using Biot-Savart's law. Next is again model question paper 2. Derive the expression for force per unit length on two infinitely long straight parallel conductors carrying current and hence define ampere. Next, question number 39. State and explain Ampere's circuital law. And the second one is derive the expression for the magnetic field at a point due to an infinitely long straight current carrying wire using Ampere's circuital law. Okay. Next, 3 marker questions. Write the expression for the force acting on a moving charge in a magnetic field and explain the symbols. When does the force become maximum and minimum? You can see this is such a repeated question, very, very important question. Next, state Ampere's circuital law, use it and derive the expression for magnetic field at a point due to a long current carrying conductor. This was also there in April 2025 paper. How can a galvanometer be converted to a voltmeter or into an ammeter? Explain with diagram. This question was there in the March 2025 paper. State and explain Biot-Savart's law. Next, briefly describe the Oersted experiment leading to the discovery of magnetic effect of current. On what factors does the force experienced by a charged particle moving in a magnetic field depends? Write 3 features observed at the interaction of a charged particle in the presence of both the electric field and the magnetic field. Derive the expression for the force acting on a conductor carrying current in a uniform magnetic field. What is the nature of trajectory of a charged particle uniform magnetic field with initial velocity at an angle of 0 degree, 90 degree and in between 0 and 90 degree with the direction of the magnetic field. Next, obtain the expression for radius of the circular path described by a charged particle uniform magnetic field. Obtain the expression for angular frequency of a charged particle moving in a uniform transverse magnetic field. What is pitch of helical path traversed by a charged particle moving in a uniform magnetic field? Obtain an expression for it. Give any three comparative differences between Biot-Savart's law for magnetic field and Coulomb's law for electrostatic field. Assuming the expression for the magnetic field at a point on the axis of a circular current loop, obtain the expression for the magnetic field at the center of the loop. Next, explain the magnetic dipole moment of a current loop. Explain how a circular current loop behaves as a magnetic dipole. Explain how to convert a galvanometer into an ammeter. Next, how to convert a galvanometer into a voltmeter. Three factors on which the current sensitivity of a moving coil galvanometer depends. Three factors on which the voltage sensitivity of a moving coil galvanometer depends. Three ways to increase the current sensitivity of a moving coil galvanometer. Three ways to increase the voltage sensitivity of a moving coil galvanometer. Does the increase in current sensitivity increase the voltage sensitivity? Explain. Mention any three differences between voltmeter and ammeter. Now we'll see 3 marker questions from your model question papers. So in a chamber, a uniform magnetic field of 6.5 into 10 to the power of minus 4 T is maintained. An electron is shot into the field with a speed of 4.8 into 10 to the power of 6 meter per second normal to the field. Determine the radius of the circular orbit. What is Lorentz force, and write the expression representing this force. Explain the terms. Explain the conversion of galvanometer into an ammeter using the relevant circuit diagram and expression. Next, we'll talk about 2 marker question. When does the force experienced by a straight current carrying conductor placed in a uniform magnetic field is maximum and minimum? This was a 2020 question. What is Lorentz force, and explain the terms used? This was asked in March 2025 in the 2 marker section. Mention an expression for the magnetic field produced at the center of the axis of a current carrying solenoid and explain the terms. Mention any two factors on which the current sensitivity of the galvanometer depends. What is magnetic susceptibility, for which material it is low and positive, and magnetization for a magnetic material. Write any two properties of magnetic field lines. What is a magnetic dipole moment, and write its SI unit. Now talking about model question paper, question number 24. What is the nature of the force between two parallel conductors carrying current in the same direction and in the opposite direction? A current loop of magnetic dipole moment of 10 m square is freely suspended in a uniform magnetic field of 5 into 10 to the power of minus 3 t, and the plane is present in the direction of the magnetic field. So calculate the torque. Next, give the vector form of Biot-Savart's law and explain the terms. Okay. So my dear children, as I told you, these are the most important questions from the chapter Moving Charges and Magnetism. And if you need any help in this particular journey of your preparation, I can mentor you. I have guided thousands of students and can definitely help you. So the link to book the mentorship session is there in the description section. So children, please don't panic. Don't waste your time. Whatever energy you have, use it in your preparation. Okay. Don't get demotivated. Don't get stressed. That will all lead to wastage of time. Only and only focus. And if you have no idea where to start, I have started this 21 days challenge. You can join this and start your preparation. Okay. So all the best, and if anything else you need that I can help you, do let me know in the comment section. All the best, keep working hard and keep studying hard.